Okay, so now for this section, I'm going to have you draw on your knowledge of fractions and what we just discussed in the previous video about when there's no relative motion in the system, then we find that the frequency of the listener, the frequency that you observe, if I am the source and I'm speaking in a classroom and I'm not walking towards you, but I'm in the same spot and I'm not moving and you're not moving, then every participant in the system is going to experience the frequency at exactly the same frequency, right? Which means if I emit 400 hertz, you also observe or you listen or you detect 400 hertz. But now let's come to where Doppler effect is in actual operation, right? I'll start with case 1. Case 1, I'm going to say, is the source moving towards a stationary listener. So source towards stationary listener. Okay, so the source towards a stationary listener. Now, if you look at this formula, if the listener is stationary, right, I'll start off with FL is equal to this bracket, V, and the listener is stationary. If the listener is stationary, the velocity of this thing over here is going to be 0, which means on top, you're only going to have V. Okay, then we go to the bottom, and we see that I've got V plus or minus Vs, okay, and Fs over here. Now I want you to think very, very carefully about this multiplier. If you think about this multiplier, guys, I'm now going to say when the source moves towards a listener, it appears as if though the frequency is higher. It appears as if though the frequency is higher. Now when you make comparisons and you say things like higher, it must be higher than something. And in this case, it's going to be higher than the frequency of the source. Higher than the frequency of the source. So in other words, FL for this case must be greater than Fs. Now, think about that. The frequency of the source never changes. It never changes. It's emitting at 400 hertz, but if the source starts to walk towards you, it's going to sound louder and louder and louder. And when we say louder, sounding louder, we're saying louder than the frequency of the source. Now, I want you to think again about this multiplier. The multiplier in this case is a fraction. Okay? So you see that that multiplier is a fraction. Now, for a fraction, if I want FL to be greater than Fs, the Fs must be multiplied by something that is greater than 1. This is maths. Okay? This bracket is multiplied by this thing, and I need this thing over here to be bigger than 1. Now, for a fraction to be bigger than 1, the numerator, the number on top, must be bigger than the number at the bottom. The top must be bigger than the number at the bottom. Now, also remember that V is exactly the same thing. This is the same value on top, and this is the same value at the bottom, but Vs is the velocity or the speed of the source. Now, if I want to make the numerator bigger than the denominator over here, or the top bigger than the bottom, and that is the same, I must make that a minus sign. Okay? I must make that a minus sign. In other words, I must take away from it in order for the top to be bigger than the bottom. That's case 1. In the next slide, let's go to case 2.